Thank you to joining my presentation. Today, I talking to the how to balance safety and hardware decoupling in SoDeV. It's my activity of SoDeV development. First one, speaker information. My name is Naoto Yamaguchi from AISIN Corporation. My boss should be said my company name to this. It's important point. And today, I'm talking about the safety point, safety information. And this photograph, hardware-defined safety. My head is very safe. Other one is not important point. All of us skip. So today's talking overview is this one. First one, SoDeV review. It's aimed to the sharing for SoDeV architecture. Some point of overlap of the Sakabe-san's last talk. Second one, existing work for AGL systems. It's aimed to sharing for safety for telltale future. It's work on AGL Instrument Expert Group. Third one is the consideration for telltale on SoDeV. It's the main content of my talk. So it aims to the SoDeV design. It aims to share the SoDeV design and discussion. Let's start. First one, SoDeV review. So it picked from the dance keynote. So today's software having the many ECU and every ECU couple for each hardware. So future prediction of the AGL. Many software run on the hardware decoupling layer. So SoDeV guy said Virt IO. So it's this hardware decoupling layers. One of the candidates is Virt IO. So what is Virt IO? So AGL focuses on achieving the hardware decoupling. So our AGL proposal is that Virt IO is a common and generic hardware interface in automotive systems. This figure shows the overview of the Virt IO. That key point is that Virt IO is a standardized interface for efficient IO. This one in virtualization environment. It makes a fast communication between the guest VM and the host. The guest sent a request to the host through Virt IO instead of using real device. It's an open standard. Some open source software supported it. Linux kernel, Zen, KVM, and QEMU, and etc. This Virt IO achieves the software reusability between automotive systems. This figure shows the high-level overview of the SoDeV architecture. So SoDeV covers wide functional domain of large-scale vehicle ECU. So many features achieved by this DOMU domain. So this figure combines the one box, but this box have many virtual machines. So inside and outside of microcontroller and the hard real-time function is out of scope of the SoDeV development. SoDeV development focuses to hypervisor-based infrastructure, and that's just an example. More detail of the SoDeV architecture part. SoDeV development focuses on hypervisor-based infrastructure, and just an example. This one is the infrastructure part. This one is the guest part. This infrastructure is built on a type 1 hypervisor. The first reference uses Zen. it has a device-specific domain. It's isolated from the hardware decoupled domain. First one, guest domains. It's focused this domain supporting use case. The supporting use case is infotainment systems such as Android Automotive OS and AGL IVI are supported, as well as AGL Instrument Cluster. This one. Architecture design aim to follow other use cases such as ADAS, AD, and connected gateway, and others. So in afternoon, we will talking another guest domain example by who's the guy. So another one is the driver domain. So the special point is the two isolated device-specific domain. One is the flexible domain. It follows various devices to support various use cases. It's built on Linux. Another one is the real-time domain. It follows a limited device to support real-time use case. It's built on RTOS, for example, the Zephyr or RT Linux. It's a driver domain part. The recap of the SoDeV. SoDeV is a reference SDV platform that is accelerated by open source technology. So SoDeV focuses on the hardware decoupling to realize software reusability. It's accelerated by Virt IO infrastructure. VM-based architecture to realize system scalability. One system have 2 VMs. Another big systems have 10 VM. It's okay. It's okay. It's accelerated by hypervisor infrastructure. So integrate deterministic and non-deterministic software into one system using the VMs. So remote rendering capability for deterministic domain accelerated by unified HMI. Today is a skip this information, but please this information talked by Panasonic yesterday. So and accelerate some SDV trends such as the cloud development others. These are researching point of the SoDeV. Next topic is the existing work for AGL systems. This work worked by AGL Instrument Cluster Group. It launched at 2019. So this expert group target is instrument cluster and IVR into one systems. This one. So platform architecture aims to support the functional safety because instrument cluster have a functional safety. Required this functional safety. So this easy aim to create the best platform built from open source technology. This best platform, open source version of the best platform, not supporting the functional safety because it depends on final system design. AGL provides a seed for supporting the functional safety. So point of the instrument cluster function safety. Typical instrument cluster assigned HLB. So because it includes a telltale function that is assigned on HLB. This HLB decomposed from other unit. Existing instrument cluster does not have HLB from own functions. All of the decomposed from other unit. So instrument cluster expert group architecture is one more isolation method from safety island architecture. So safety island isolated main part by low-level isolation method. For example, the hypervisor and hardware level AMP design. So safety function is built on safety island, and the main function built on Linux with container. So using the container is a difference of the SoDeV architecture, but the overview design is the same as SoDeV design. So today's topic is how to balance the safety and hardware decoupling. Important point is share for the safety use case. I talk about the telltale use case. The first one, I share the example systems. This system having the A3X, D, C, B, I don't know, so one of the example. And the instrument cluster are connected by CAN interface. So this is must avoid misnotification by telltale. It assigned ACB. So cluster output safety control signal separately from output display output. When safety control is enabled, cluster display shows the failure information. It's a recap for Safety Critical Summit in 2019. So more detail as shown. It's a structure. So safety function side can receive telltale information. Warning indication is necessary or unnecessary. Main function side can receive the telltale information from safety function side. Safety function side can receive. So telltale function judges whether telltale information is necessary or unnecessary. When it is necessary, telltale function draw to warning indication on normal display output. Listen. Display output checker calculates the CRC of the image inside a window. This window, it's shown on this figure. This window is set to the position where warning indication should be displayed. In this case, display output checker uses specific hardware. So next one is a checking point. So image CRC calculator calculates CRC by correct image from another source. It stays on the inside of the safety island memory. In this case, image CRC calculator knows which image should be shown by CAN receiver. This information get from safety side CAN receiver output. So CRC checker compares the CRC value output from image CRC calculator and the display output checker. If they are match, failure handler is not work. If there is a not match, that means telltale function shows this image, but the correct image is this one. Failure handler enables safety control. This example shows a more big alert. It's a inspector cluster inspector cluster AGL telltale design. So the point is this architecture. Point one. Safety telltale is built by deep combination between main function and the safety function. Point two is a safety function built by deeply combination between hardware and the software. This one and this one. So recap for instrument cluster. Easy defined a two-layer isolation architecture. So one approach is an isolation between QM blocks, and another one, today's main topic, is the functional safety approach, is a safety island architecture. It achieves FFI, freedom from interface, that support isolation between the ASIL part and the QM part. On the other hand, FFI does not realize the hardware decoupling because original design is a hardware coupling. Hardware coupling design. The telltale design is built by two software blocks that depend on the hardware design. In case of IC's architecture, it is not intended for the full hardware decoupling. It's a not matching point of the SoDeV architecture and the IC's architecture. IG architecture can achieve this telltale. But SoDeV architecture aims to achieve full hardware decoupling. In this case, it's a big gap. So final topic is the consideration for telltale on SoDeV. So what is the issue? SoDeV aims to create a reference SDV platform that features the hardware decoupling for guest domain using the Virt IO infrastructure. Some guest domain features require safety, such as the instrument cluster. It includes the telltale function. It's a recap of the existing talk. So consideration point in this talk, so existing telltale design coupled between software and hardware. How to balance the safety and the software decoupling. It's a main topic. Attention. So Zen Hypervisor and the Zephyr are those not working for safety certificate. Now working to certification. Now working to get a safety certification. When Zen and Zephyr get an SLB certification, is telltale feature on SoDeV safe and aligned with SLB? That answer is no, because hypervisor supported SLB, Zephyr supported SLB, but the system, it's a part of the systems, not all of the systems. So if a SoDeV-based system needs to align SLB, we shall design a system to align SLB. In this discussion, assume to Zen achieved an SLB aligned FFI and Zephyr achieved an SLB aligned runtime environment. It's a precondition in this talk. So design number one. All of the instrument cluster functions stay on the DOM view. It is isolated from DOM view, for example, the infotainment. The safety function is built on virtualization layers, this one. The safety function depends on the DOM view safety because it uses DOM hardware using Virt IO. But do not need telltale special interface between the instrument cluster, DOM and other domains. So analyze for this design one. So strong point is that all instrument cluster software will be easy to upgrade because all in software integrated to one VMs. But the weak point, so all instrument cluster software shall be aligned to SLB because it includes the same binary, same VMs in worst case. It includes the main function and the safety function. So both DOMD shall be aligned to ASIL. It includes a root of the telltale showing and the failure path. So safety function using the hardware, it controlled by Zephyr real-time DOMD, and the display output controlled by the Linux DOMD. It's worst case. Next design is number two. telltale drawing function stay on DOM view. It's not required AISIN in this model case. So telltale monitor part stay on DOM view for safety, DOM view for safety part, for safety side use case. It is isolated from other domain. It's isolated by other domain. The safety function is not built on virtualization layers. The safety feature depends on only DOMD for safety. On the other hand, the telltale special interface between the instrument cluster DOMD and the other domain is necessary. That means main function draws the telltale in this position. Please check my telltale. It's one example of the special interface for telltale between DOMD and DOM. So that starting point is possible to reduce the AC-related part from design one. It requires only a DOMD for safety. Weak point is necessary for the telltale special interface between the instrument cluster DOM and DOMD for safety. If change the inside of the telltale drawing area of DOM, that affect to DOMD for safety. That means restricted the instrument cluster visual design by DOMD side. The drawing image and the position must match between telltale drawing and the telltale monitoring. If it's a match, this safety control is enabled every time. Design number 3. All telltale functions stay on DOMD for safety, but clusters another function stay on DOMD. For example, speed of information. Forcefully overlay the telltale image, including the background on DOM image. Non-telltale function in instrument cluster stay on DOM. The telltale feature is isolated from the other feature and from other instrument cluster functions. It's this design. So instrument cluster function is decoupled from safety. This one and this one. On the other hand, instrument cluster visual design restricted by the telltale function on DOMD for safety. So good. Strong point for this design. So possible to reduce the AC-related part from design 1. It's same situation for design 2. A weak point is the instrument cluster visual design must be for the telltale layout. Get the telltale area from DOMD for safety by the platform configuration interface. This instrument cluster visual design on DOM is coupled with DOMD safety. That means DOMD notificate to DOM instrument cluster. This area shows a telltale should not overlap other information. Last, another idea is that telltale functions stay on the microcontroller outside of the SoDeV. It uses physical telltale, example of LED. This picture is AGL official demo using the LED. It achieves the full decoupling from others. Another idea is currently I don't have now. So which design is a better balance? My answer is the design number 3. Instrument cluster function is a decoupled from safety. It's a design number 3. Because instrument cluster physical display does not use the same aspect rate and resolution. These are a big instrument cluster example. It's a typical pattern, more another pattern, and more special pattern. When SoDeV aim to decouple hardware, these physical display variation issues shall be resolved. What I mean, this design issue is not only a telltale, all of the displayed function. So this issue is similar to design number 3 weak point. That is, instrument cluster visual design must be follow the telltale layout. But other than instrument cluster design must be follow the display layout, display size, and the resolution. It's the same situation. That means that issue is not limited telltale. So conclusion. So reviewed for SoDeV architecture and my recapped from AGL Instrument Cluster Expert Group activity on telltale future. It's the first topic of my presentation. So these are the starting point of the consideration for how to balance the safety and hardware decoupling in SoDeV. I show the 3 designs to discuss safety and hardware decoupling balancing. My proposed design, the candidate design for telltale features. But it's only one case. I need to discuss other use cases in SoDeV because SoDeV aims to support another safety-related use case. We'll discuss other use case in AGL community. Welcome to your contribution for the SoDeV works, and welcome to join the SoDeV Easy Talk. That's all my presentation. Thank you. Oh, yeah, please.
I am a little bit hesitant to make a comment on this, but because Toyota is also participating in the SoDeV activities partially. But I need to say this, I think. The concept of having the D domain, device driver domain, is bad. I drew up the very similar architecture 25 years ago for the game console, but I gave up and put all the device drivers shared among the multiple partitions into the hypervisor itself. It's a messy situation happening in the development of a hypervisor, though, but it makes a good performance. And the concept of having the multiple partitions for multiple roles on top of hypervisor is a good concept for the making good throughput in the server-side domains. But for the embedded systems, the throughput is not a big concern. The latency, response time is much more important. And also, like this, functional safety type of thing is important. And then we actually, I thought what was the best architecture for that. And then finally, I decided to put the all shared device drivers into the hypervisor. And that, needs only only one hypervisor call initiate the kicking the drivers and so on. But if you have D domains, then you have to send the message from the U domains to D domain. Sometimes it needs to send the big data. And you might need to copy all those kind of data in a message. Or even though that if you have the zero copy type of sharing memories across the partitions, but you have to manage who owns the portion of the memory areas. And if the multiple U domains send tons of requests to D domains, but D domain doesn't have a capability to consume the data, then all the memory area which must be owned by U domains must be, it's all gone. So it's really, really hard to make a balance for consuming the resources, especially in memory and other spaces. So we decided to put a hypervisor. And in case of the, the safety critical portions, I think it's better to put the kind of monitoring capabilities aside the actual functions, like a separate MCU or something like that. So that's a typical architecture, I think. So that's the reason why Toyota is not so serious about to implement the SoDeV architecture into a real product. So, but I shouldn't say that these kind of things for the actual productions, but if the AGL is going to the meshy world, I cannot stop to saying these kind of things in this meeting. So that's why I'm making a comment on that. So please consider that kind of a real-time response performance more than the throughput. The many software people who are writing in the system architecture and the software on top of the hypervisor system in the cloud or servers, they prefer to use this architecture. But we are in the embedded system domains, so we have to consider that much more, real-time response performance than the throughput. That's my comment. It's not for you, but probably as to you, Sakabe-san as well.
My response is, my understanding is the same as Mura-san. We instrument cluster AG and selected the container. It's that point.
So for ASIO, it's a very similar thing. And telltale cases is not big issue because probably it's if the telltale indicator is the 1 second delays, that's not a big deal. But for performance, especially for GPU, probably I guess Unified Edge might use some device drivers inside each hypervisor to making arbitrations. Otherwise, the GPU is pretty much background for doing something. So same things could be applied for I2C, I2S, or other, the storage devices and so on, because it requires a much more faster response for that. So that's, we should think about that kind of things more.
What? Finish? So my presentation is the time is over, but today I keep my time slot. Thank you.